So welcome back. Example number 3 from chapter 7. Quickly, you can recognize that this is pretty much exactly the same as example number 2, which I thought needed another look, especially the part about verifying the claim. So jumping right in, we see that we wish to assess whether more than 60% of US households in a particular income class bought life insurance. So right off the bat, we know exactly what we're looking for. We want to know if the true proportion, population proportion, is actually more than a certain number, in this case 60%. So to do that, an insurance company took a random survey, or a survey with a randomly selected sample of 1,000 households, and they've observed 640 that bought life insurance. So immediately we can say that the sample proportion is 640 divided by 1,000. I know you know this, so 64%. Isn't this weird? We took a sample and it was 64%, but the population proportion is supposed to be something like 60%. So the fact that they are different raises a few flags, and this is what we're trying to verify here. And to verify this, the question A says, well, look, tell me, what's the probability of finding a sample that big or bigger? At least, right? So that big or bigger. So find the probability of finding a sample with an observed sample proportion of at least 64%. So z is equal to p hat minus p over the standard error of the sampling distribution of the sample proportion. Remember that the standard error here is nothing more than p, 1 minus p divided by n. Take the square root. So in our case, 64% minus 60. And again, always check my math. So we're looking for a z value of 2.58 or greater. What is the probability of observing something that is 2.58 standard deviations away from its average? And as always, it's always good to maybe draw a little bit of an illustration, especially on exam situations, just to have clarify where things are. So this is where you are here, and you found a sample here, 64%, and we found that its z value corresponds to 2.58, and essentially what we're looking for is this shaded region here in green. What is this guy? So to do that, simply need to apply the use of the standard normal chart table. Before you do that, maybe you'd like to check out that the sample is large, so n times p should be greater than 5, which it is. N times 1 minus p also should be greater than or equal 5, which it also is. Once both of these have checked out, then we can use the standard normal distribution table. So this is the one that I'm using. Again, it's a little bit different than the one you use on the exam or the one used in the book. If you have any issues, please don't hesitate to contact me. So I'm looking for 2.58. So this is 2.5. I go all the way to this column right here. I can't see the heading, but I know that the last column is 9, so the one before that has to be 8. And so it's telling me that the distance between 0 and 2.58 is essentially 49.51%. Okay, but I'm not looking for that. I'm looking for this area right here, the remainder. So to do that, so the chance is very minute. It's 0.5%. So question B says, based on your answer, do you think that more than 60% of all US households in the income class bought life insurance last year? And the answer has to be yes, because if you remember from your empirical rule, 68% of things have to be around the average. The fact that you took a sample and it wasn't within that 68% range indicates that maybe you miscalculated the true proportion of the population. Maybe that proportion is actually much higher than 60. Maybe it's a lot closer to 64 than you think. Maybe it's 63.5, for example. And if it is, then it would make 64 not look so strange. The idea here is that you shouldn't observe strange things, but the fact that you did should give you pause, and you have to think, well, maybe my starting point was incorrect. Now, of course, you could have totally randomly observed a sample with a proportion of 64% just by pure luck. But the more likely solution is that the reason you observed something so strange is that it's not actually strange. It's you who was incorrect by assuming the population proportion was 60% when in fact it's probably much, much larger.